Now this lecture we are again discuss about aggregate. As I said earlier, aggregates also inert material around 99%, maybe 1%, 2% aggregates are reactive in nature. Depend upon the source of the materials. But they are very, very important to know their properties for their applications, as well as getting a good workable concrete and durable concrete. One has to understand aggregate very, very carefully. We cannot leave it to the, because right now aggregates are not yet coming from the corporate organizations. It is all by the local people they are manufacturing. So their logic is just get the rock, crush it and give it to them. But that may not be satisfied with our now whatever concrete we are looking at in recent years. We are talking about not the strength, we are talking about durability, getting the good finish, then life of the structure due to the concrete. So those one has to understand very carefully which aggregate I am using and what are their effects. So about shape, we are discussed in last lecture. Now further testing we'll discuss in this lecture. So that flakiness index and elongation index, then shape, the what is the surface area, those I think we are discussing last year. Now we are taking the what are their other properties in aggregate. Now we are just covering about coarse aggregate. So aggregate crushing value is one of the tests, how it is tough aggregate for the load, then aggregate impact value, then aggregate abrasion value. This value basically when you are working for roads or factory floors where a lot of impacts are coming on the, because a lot of weights were dropping on the floors, and there your floor should not be damaged very easily. So aggregate also needs to be tested for impact value, abrasion value. As I said, some of the aggregates in nature having a lot of infillings which are reactive in nature, reacting with alkalis in the cement. Cement is alkaline in nature. So if the silica is reactive silica is available, you get alkali silica reaction. And once you get that reaction in presence of temperature, normal temperature and water, it concrete swells and then it cracks. So whatever you are using in concrete, you must test for this particular test also. And there is a petrographic analysis. You must have heard of in your geological lecture. What is the petrographic analysis of rocks? So similarly, there is in concrete, because there are a lot of issues also, because once it is formed from the lava, there is a, depending upon their cooling process, it develops the various what you call defects in the concrete, and then one has to understand in the aggregate rather. And those all the test methods for the how to test the aggregates, both fine as well as coarse aggregate, are given in IS 2386 part 1 to part 8. I think this is one of the code all civil engineer must having, those who are really interested to go in the concrete or concrete technology area. Now this is the comes under mechanical properties, aggregate crushing value, and there is another test called 10% fines value. So in aggregate crushing value, what you do is you take particular fraction of sample, put it into the whole assembly into the your compression testing machine, apply load about 40 tons, and then under the 40 tons, how much material passing to the particular sieve, that you have to find out. If the aggregate is very hard, that passing percentage may be low. If the aggregate is very soft, the passing percentage may be high. So there are two limits they are given in IS code. These limits are given in IS 383 and method of test is given in IS 2386 part 4. All the mechanical properties are given in part 4. There is a 1 to 8 I said. So this is in part 4. So whenever you are using aggregates for wearing surfaces like runways, roads, pavement, tunnel lining, which is carrying water, because these also get a lot of abrasion and spillage. So all this material we cannot use aggregate which is having aggregate crushing value more than 30%. So this is the limit. Whenever the application, when you are using for roads, you must see that. But normal building, this limit is, you can go up to 45%. But for wearing surface, you can go up to 30%. So that one has to understand. So which application you are going, that you have to understand, and accordingly you check the quality of aggregates available in that particular area. Suppose they are not available, you have to go from far away, and that will increase your cost. Now, whenever there is a wearing surfaces, your aggregate crushing value exceeds 30%, then you test for 10% fine value at 50 kilonewton load. Here I said aggregate crushing value 40 ton. So you apply 50-ton load and see to get 10% fines, how much is the load is coming. So that is a 10% fine value. Generally for lightweight aggregate, we do this test. It's not very common test, but this test now they are included also for the wearing surfaces of aggregate. So one has to understand whatever aggregate I use that has to be tested depending on application. Suppose you are making a roads, and you must have seen in the road a lot of uh, wearing taken place within May 1 year or 2 years. So the quality of aggregate is also get a major role in that. Even in Mumbai BMC road or any other road, if you see, if you use aggregate is that not that quality, definitely there is a issue in surfaces. So aggregate impact value wearing surface 30%. Other than wearing surface, mean any building and other things are there where the average doesn't take place, the limit has increased from 30 to 45%. Still it is acceptable. Now the new requirement has come in IS 2386 2016, because this code about 383 has now recently revised in 2016, and now we are going always a very high grade concrete M60, 70, 80, 90, 100. So here they say this limit gives to 22%. Even though wearing surface is 30%, for concrete grade more than 65 plus, the strong aggregates are required. There his limit is given is 22%. So this has to be remember always. When you are going for high strength concrete, you must see what is the aggregate crushing value, aggregate impact value. Then there is another test called aggregate abrasion value. Generally, this test we do only for when you are going for pavement quality or road or runways. Here, again, it is 30%, and other than wearing surfaces around 50%. This is also simple test to see the wear. You take particular charge, put it in the ball mill type thing, and revolve it for 1,000 revolution or 500 depend upon the grading, and see how much material passing to 1.7 mmcu. That is aggregate abrasion value. It gives fair idea about how aggregates are standing for those wearing forces. Now there is a part number 5, IS 2386, soundness of aggregate. Soundness is nothing but when the changes come for temperature as well as your humidity. You get summer very hot, then winter get very cool. So in that fashion, when it is goes with the number of times, you'll find concrete its your aggregate itself are disintegrating. To simulate that phenomena, they have designed a test called soundness of aggregate and loss of mass after 5 cycles. So there is a two solutions, like Na2SO4 and MgSO4. So you take saturated solution of this Na2SO4 and take the particular fractions of aggregate, weight initially, put it into the solution for 18 hours, saturated solution where you can see the crystals also, and then you remove it after 18 hours and put it into oven for a temperature of 105 degree, 110 degree, 100 to 110 degree for 4 to 6 hours. So this called one cycle. So put it into solution, remove from solution after 18 hours and put it into the for higher temperature at 100 degree for 4 to 6 hours. So repeat this cycle 5 times. And end of the five cycle, you will find your aggregates are disintegrated. What is happening is in this whole process, when you're putting on dried aggregate in the solution, so what is porosity is there in the aggregate, it absorbs the saturated solutions. And once it is absorbed, they because since it is saturated, it form a crystals. And always crystal has got more volume than its solution. So you give some stress on the aggregate, internal stress. That is for 18 hours, 18 to 20 hours. And then you remove this because that will come under stress. Very high porous aggregate will give more loss. Dense aggregate will lower loss. So once you put that saturated aggregate into the oven, the stress is released because it is melting again. So what you are doing, you are giving stress and also you are releasing the stress. So that one cycle, if you read 5 cycles, you will find aggregate are literally disintegrated. And then that whatever fines has removed, that we have to pass through the particular sieves and see how much loss is there. So this is loss of mass, and that is should not exceed than 10% for Na2SO4 and 15% for MgSO4. This is for fine aggregate, and for coarse aggregate, this is 12% and 18%. So this also test whenever you're going for new quarry or very important projects, because when the you are going into the foundations, there is always the seawater will come to the concrete, and seawater, you know, it is 10 to 15,000 NaCl is there, sodium chloride, and these form of crystals. So that whole process, when high tide and low tide, same phenomena take place, and your concrete disintegrates. So we should have a proper aggregate selection for the particular projects. Then alkali aggregate reaction. This is a chemical test. This also, as I said, this alkali is available in the cement and silica available in the aggregates are form a calcium sulfoaluminates or alkali silica. It has got expansion, means it's got volume change and it disturb. There is a chemical test given for this. For that is for, we can say, very fast test within say few days, within 3 to 4 days we'll understand the quality of aggregate. And there is another test given is a mortar bar test. So you take those aggregates, particular fractions, prepare the mortars and put into the solution. But that test goes for 6 months to 1 year also. But that is very important when you are working for a very big project like nuclear projects or dams, there we have to go for such test because we not take a risk, because once you have constructed the structure, it's very difficult to repair it again, because these whole aggregates are throughout the body of concrete. As I said earlier, it is around 70-75% is only aggregates, and if that aggregates are reactive, definitely we'll have issue in concrete. So alkali aggregate reaction is also a issue in aggregate. You must have heard about Bhakra Nangal. When they have constructed that dam, there's some portion as having alkali aggregate, reactive aggregate. They found some cracking in the concrete. And that is only due to the aggregates are reactive in nature. This is what we are calling the normal aggregate or natural source aggregate. Also, there is a manufactured aggregates, as I explained earlier. So there also additional requirement they are given. Alkali content as a equivalent to Na2O 0.3%, because they are coming from industry. So a lot of industrial waste which may come into the aggregate source. So that's why these limits are given for manufactured aggregate. Like your slag is there, or copper slag is there, or any glass is there, that also can be used as an aggregate. Even where your burnt clay bricks, if you crush it and make it aggregate, yeah, that also you can make. But those raw material may contain lot of impurities that one has to test. See, water absorption given 5% and specific gravity. This is for normal aggregate 2.1 to 3.2. So normal aggregate, they are not given any specific gravity limit. But manufacture aggregate, definitely there is a requirement. This is from IS 383 2016 clause 5.7. So you must be aware of this. So what are the impurities available in the aggregate itself, which may affect the performance of your concrete. Then effect of size. As we say, we are going for right around 20 mm to, I'm talking only RCC structures. So RCC structures, we are going for 20 mm to 150 micron. Now we have aggregate generally as a people are understanding, or the engineers are understanding in the three fractions. Three fractions is 20 mm, 10 mm, and then your 4.75 passing is your sand, called a fine aggregate. So whenever you're designing any mix or selection of mixed proportion, you have to keep, as earlier we have discussed in last lecture, as your size goes down, your surface area is increasing. Once the surface area is increasing, definitely your water demand is increasing. So larger size giving lower cement content, and smaller size given higher binder content or cement content or water demand. More aggregate, larger size could improve the wear resistance, but there is a chances of segregation of particles, means they are going away from the main mortar of concrete. Now, as large as possible you have to go, but as per normal our practical purpose, we are going with 20 mm or maximum 25 mm, but now most of the aggregate go with 20 mm only. When your reinforcement and element is allowed to go more than, we can go also 40 mm aggregate, especially for foundations where large pores are there, large size are there, and very nominal reinforcements are there, we can go even 40 mm aggregate. But there is a limit to go for the higher size of the aggregate, because then efficiency of aggregate size also come in the picture. We cannot go on changing on this particular phenomena, like larger aggregate more strength, but it has got also efficiency of that particular. In more detail you can read SP 24 special publication of IS. They have given the detailed explanation about this, how the your efficiency of aggregate also came. But normal our practical use, we are only concentrating on 20 mm aggregate, then 10 mm aggregate, and then material which is passing 4.75 you call as a sand. So as a concrete technologist, your aim to have a coarser proportions as far as possible without losing this. You should not have segregation and also you should not lose it. So that is a basically a what you call your skill of the engineer who can decide how to go about the proportioning of 10 mm, 20 mm and sand. Certain guidelines are available, but those guidelines are only to you go what a particular direction. But ultimately, as an engineer, you must take care or you decide rather how to go about proportioning. When you're discussing about mix design, we'll discuss in detail about this. This is also same put it into the graphs. You see the nominal size 20 mm, maybe cement content about 350. Now same water cement ratio and slump. My size suppose goes 40 mm, my cement content go to maybe 275. This is all plays about the surface area of your all the particles available in that unit volume. So when you are doing adjustment in the mixes, there you know this, you cannot do whatever proportions they are using and suddenly one particular fraction is absent and without changing the proportion we cannot go with the mix design or in the production of concrete. We'll have a lot of issues that one has to understand. So it is very clearly indicated that lower size, higher binder content, more size. But this has to be again optimized at the particular application. Now, why we are specifying the grading limits? Grading is the particle size distribution of the materials. 20 means we don't have 20, we have 20, 12.5, 4.75, 10 mm, then 4.75, 2.36. So various small fractions are available in the particular grade of a particular size of material. So IS has given certain grading limits, and we have to see that those grading limit you have to maintain for a better concrete. So relative proportioning of aggregates. So we have to proportions say 20 mm, 10 mm, and 4.75. This is also affecting your cementing materials. How much consumption is there? How your binder content? That you decide on your proportioning. Your coarser side proportioning will give lower cementitious material, and finer side will give always a higher side cementing materials. Your water requirements, your workability requirements, all are related to the grading limits available for the particular set of material. Once those are changing, that needs to be changed the proportions to maintain these parameters like workability and pumpability. Maybe grading may change, but this has remained constant for the particular application that one has to see, and accordingly you can design your mixes effectively. Then economics also, because this all related to cement content, then economics will come in picture. Porosity, porosity in the sense number of voids available in the unit volume of those 2010 and 4.75. The more volume, more voids, more paste will require. Now more paste will go for more shrinkage, because in this whole process, shrinkage cement is having one property, gets shrinks. So whatever coating we are preparing on the cement particles should be minimum thickness possible or practicable, or it is for binding whatever minimum required. We should not have a more binder and less aggregate about a particular mix. You may find there's a lot of shrinkage of concrete because your aggregates are stable. Coefficient of expansion is very low for the aggregates, good aggregates. And then once this is less, then your durability also improves. So ultimately aim is to go for durable concrete. So whatever design life, maybe 80 years, 100 years, 120 years, that has to be achieved. So those will decide depend upon your specifying the limits of your grading. Here also you can just, this is one study conducted in our R&D division that time. You can see here cement content is same 300 kg. Now here fractions are varying. Here 26% 0 to 4 mm and here 60%. This is finer. This is coarser. Now here see the water demand and see the water demand here. Now if you keep same cement content, then water has increased, water cement ratio has reduced. Flow is more or less because to achieve the flow, you increase the water content and see the density here and see the strength. This is 37, this is 26. This gives very clear picture how your number of fractions in the particular aggregate is changing. So here 41% is 11%. So this is the coarser one, this is finer one. So finer material required more water. Keeping same cement paste, this is what we're doing because cement is costliest. So people don't want to increase the cement content. They increase only water content. Then you have a loss of strength. This is most of the site it is happening. So appropriately I had to correct. Suppose 198 is there, then I go 0.5 and increase this binder content. Because your fines are more here, so you require more surface area. So more paste is also required, not only the water. So you have to adjust always the paste, not only the water. Keeping same water cement ratio, which is what is your aim, 100%. This is one has to understand as a concrete technologist how the grading influence on your workability as well as on the strength parameters. It is you understood, but you have to repeat this, read again and again to understand the concept. Once you are able to understand this concept, it's very easy to go for proper mix proportioning and very good concrete mix design. You can see here. This we have single size aggregate, poorly graded. See, this is all how much mortar is there. See, white is all mortar. And now if you have graded aggregate, you see the mortar content is very less. So definitely this is the better concrete than this. Now this is the grading requirement given in IS 383 2016. So when you're going for mixed designs, always you have to follow some pattern. So single size aggregate, single size in the sense you get one fraction called 20 mm, another fraction called 10 mm. This is commonly used aggregates, but this is also available sometimes. So we can go with selection of this which particular fraction. In this, suppose you take 20 mm, so 40 mm 100% passing, all the particles are passing to 40 mm size. Then 20 mm 100% or 85%. What it indicates that 15% ore size is allowed that particular size of material. So 20 mm, 20 mm, here 85 means 15% coarser material is allowed. If you see all the gradings here, that is very easy to understand. See 85, 85, 85, 85, 85. And what they say, 15% ore size is allowed, that particular size of aggregate is allowed. This is in single size aggregate. Means you get 20 mm aggregate, you see this grading. So one this grading is there, 10 mm is there, and then 5. They should not be a very fine material, because 4.75 we have sand will start again from here. So you have combination of this and then combination of this. Now you have 10 mm. Then here some aggregate is there, say with 20% or 0%. Then 8500 is coming from 10 mm size. Then 4.75 and 2.36 is 5. Now this also need to be understand how much percent is there, and accordingly your fine aggregate you must be select properly. If you add more sand also, because in sand this fraction is also available. So when you are using 20 mm, 10 mm and sand, you must go for proper understanding of proportioning of materials. And this is for graded one. Graded in the sense you take 10 mm and 20 mm, combine in such a manner that you should get always in this range. So here is 10%. See, this most commonly used aggregates is 10 mm and 20 mm. So 90, 100, 25, 55, 0, 10, and then 90, 100, 40, 85, 0, 10. So in combined aggregate 4.75, hardly 10% is allowed. So you get this grading and combine in this to get this graded limit, graded combinations. So we are going for 20 mm. So here up to 10 mm is also there. So 10-20 combination we should have this. So in generally go to the site, people use 50-50%. So depend upon their particle size distribution, you check whether they are falling in this limit. This is a finer one, this is coarser one. So try to match in between at a middle point. This also we can put in the graphically and check how it is go into this. When you go for the mixed design, we'll discuss on this. This is very important to see, and these are all guidelines for the. Sometimes you may not get this. Then you do real testing, when a real take a trial, and then you understand how it going for the mix looks like. Now there is also given for mass concrete. So huge mass concrete, when you are using about 150 mm or 80 mm aggregate, there also they are given the limits here. Now this is included in this IS 2016. So this is a similar concept based on the aggregate. When you are going for plumb concrete or large pores or only filler, where we can go for such larger size aggregate, even 150 mm, 80 to 150 mm size. This is grading limit given for the aggregate which is available in nature in mixed form. That's why they call all in aggregate. If you go to the river beds or you go to the northern India, most of the river beds they are having lot of aggregates, means gravels. Earlier lecture we have shown the gravels, which is the coarser material of your river sand. So they are available in mines also, means your river beds. If you excavate, you get those aggregate coarser material, and they are available right from 80 mm to 150 micron. But generally our interest is this 20 mm to 150 micron. So for this, so here again 9500. But here overall grading they are given, right from 20 mm to 150 micron. Earlier slide we have seen only 20 mm to 4.75 up to this. Now the limit is given up to sand, because in river bed sand also will come. So there also we can utilize this table, table 10, and you can design a concrete accordingly.